Okay. Can you hear me and can you see my presentation?
Yes, yes.
Okay. Okay, yeah, welcome. My presentation is about the acquisition of zone interdite by Wachter Youth, made in 2000 until now, or how to preserve works made with obsolete game engines. I had this idea as the House of Electronic Arts recently acquired two artworks made with two different obsolete game engines. They are not using headsets, but otherwise there are many similarities with VR-based works. Last year, Tom, Jack, Dragon, Espenchid and me tried to migrate works made with current game engines to different current runtimes. However, if you do not have a current game engine, this procedure is not possible. That's why I thought I would speak about that a bit. This presentation is very practical. It's not a new theory or anything. It's just a, let's say, museum practice. I had a theoretical presentation about emulation of graphics intensive works at the iPress 2018. So now I'm rather speaking about practical aspects as they occur in a museum and acquiring an immersive media artwork. So first I will present you this artwork, Zone Interdite, as a case study. I will then speak about its acquisition and preservation and show how narrowly acquisition and preservation strategies are tied together. Finally, I will suggest more support and tools for graphics intensive works for museum staff and of course for the general public as well. Whoever who wants to emulate. Okay. So this is Zone Interdite by Christoph Wachter and Matthias Jude. It's an ongoing project, quite old. It started in 2000, and the House of Electronic Art is about to acquiring it now. I'm quoting from the artist website. The project Zone Interdite, French for restricted military zone, emerged from a paradox. It is forbidden to depict or enter military areas, yet these pictures appear in the mass media. The artists reconstructed the restricted zone of the Guantanamo prison through virtual walkthroughs based on crowdsourced information and insight, including prisoner testimony and freely available data. Visitors are invited to improve and complete the project with their own internet searches. I'm showing you now this video because it's much easier than explaining it, the work. It's 1 minute. Then there's no sound. The sound is only in the video. So, yeah, each of these there are 3 screens and each one is powered by one computer. They are all synchronized in a local area network and the user navigates through the Guantanamo prison with the joystick and the computer in the center of the space. This computer is connected to the internet and it presents the website zoneinterdite.net. this is the website. So the work also depends on a website and not only on this virtual or let's say on this walkthrough. So on this, maybe quickly back, on this website, the user gets an overview of the map of the Guantanamo prison, so he or she always knows where they are. And in addition, they can retrieve information about the source material used for a certain part of the prison or even add information themselves. On this, now that you know what the work looks like, I quickly summarize its significant properties. Besides the quality of the interactive video and that what we want to preserve is what, sorry. Besides the quality of the interactive video, we also want to preserve or need to preserve certain dependencies. So for instance, the video projectors have to project the 4:3 image. There's also a joystick, and both of them are generic, so they can be replaced, but the function needs to be preserved. And then there, of course, is the website that needs to exist somehow and be online and work. And the artist also prescribed to use Firefox internet browser, and you also need Flash in order to present the website. The work has been developed since the year 2000. The environment necessary to show this work changed, of course, too. In 2006, it was probably only a terminal version without the 3 screens. Back then, they used Windows XP. Today, it is Windows 7 or 10. DirectX is not needed, only OpenGL. Hence, a medium performance graphics card with OpenGL for each computer is enough for this work. The display resolution is quite strange. It's also 4:3, but it's not a very common format. And this aspect ratio, as I said, is quite relevant for the video projectors. And it cannot be just changed because, yeah, I will explain that later. And as I mentioned in the beginning of my presentation, the game engine they used is obsolete. It's Crystal Space, it is open source and cross-platform, and it was often used by artists. It is based on OpenGL, and the latest release is from 2012. At this moment, I also want to mention that the House of Electronic Arts acquired other artworks with obsolete game engines. Dark Basic is another example for a game engine that is not supported any longer. So it's kind of not such, I think it's not such a rare case. In order to get a notion of the software, I asked the artist to give me the installation package of this work. They provided me with a zip folder that contained all these files that you can see on the screen necessary to install the work. Provided the right environment is pre-installed. This folder contained the executable binary, configuration files, shader files, fonts, icons, and screenshots from different years. So you can see it varies from 2006, I think, until 2017. It seems that these files, or this, the executable doesn't work without these source files, so it only works together. And they have to be in exactly these folders, otherwise it wouldn't work. So the question for me was then, okay, what should the House of Electronic Arts now ask for? Which additional components, hardware components do we need? And for this, I had to ask myself about future preservation strategies. If you're acquiring an artwork that is already obsolete at point of acquisition. So yeah, I had to exclude migration as this game engine is not supported anymore. And also, in addition, the artists told me that the compilation was very complex. What is left is the strategy emulation virtualization, and it's also possible because the peripherals are very unspecific, so there are no headsets involved. So it was kind of clear what strategy to choose. So I wondered, what should I ask from the artist? Normally, so what I learned is that you always have to ask for the hardware, but we didn't want to acquire for computers for financial reasons, but also for space reasons. So should we then ask for 4 virtual machines or disk images? Yeah, and that's what I decided for to acquire 4 virtual machines. In order not to ask something very impossible from the artists, I thought about, yeah, what are the requirements for emulation and for these virtual machines. So because it's all Windows, well, not because it's Windows based, but Windows runs on CPU architecture x86-64. So this is the common architecture, I would say, nowadays. So the emulators need to be able to emulate that. Then networking between VMs has to be possible because they have to build like a local area network, and of course internet connection. These are all requirements that are not unusual, so this is very well possible. And the 4th requirement of performance, hardware acceleration for CPU and GPU. This is possible today, but not this simple. There are 2 strategies. It's a sub-strategies. It's called para-virtualization or GPU pass-through. And they are not so banal to really do. Sometimes it works and sometimes it doesn't. So this is my last slide. So I want to conclude that it would be nice to have like more manuals and more examples how to kind of translate a hardware and graphics chain into the virtual space. I found that there are some tools, but I've never tried them. I'm quite curious what you think about them and whether you tried these or whether you tried other ones. For instance, the Intel Graphics Performance Analyzer or the I don't know how to pronounce that, Radeon GPU Analyzer. And for the workflows, emulation workflows, there is this guideline called QEMU QED, but it doesn't contain yet any guidelines for more graphics intensive work. So they're just the standard, it contains the standard emulations of, for instance, Windows XP. And then the last point I want to stress is that it would be nice to have some test executables or test videos for standard graphics chains. Yeah. So now I'm curious about your experiences with emulation of graphics intensive works. Thank you.
Thank you, Claudia. That was great. Yeah, I mean, just to start, I think it's really interesting seeing that a lot of the problems you were talking about on that last slide there, the challenges, are the exact same ones that we've been coming across. I'm curious, how did you find those tools for analyzing the graphics pipeline?
I just Googled. That's all.
Okay.
But then I found this. What was the first one? What was the Intel Graphics Performance Analyzer, and I wanted to install it, and then I got a bit scared because it said that it will download, it will use Google, I don't remember what it was called, Google Analyzer or something, and it will download all your data. And then I was thinking, do I really want that, analyzing everything on my computer? Mm. And then I found this Radeon GPU analyzer, and this is, but I haven't compared them, I haven't tried them yet, so I'm not sure. Yeah.
I think something that Tom and I were finding when we were trying to look at like graphics pipelines is that these kind of like techniques like lens warp and stuff, and a frame warp and time warp and things, they're doing these little like sort of buffer tricks to get maximum performance out of the limited power of a graphics pipeline, and it kind of caused us to break down in our understanding of what was happening where in a graphics pipeline. Which is perhaps like a problem that you know, like a sort of VR pipeline is presenting to these tools, perhaps.
Yeah.
Sorry, what were you going to say, Tom?
I was just going to say, in the end, we kind of resorted to, we used some tools which analyze the software as it's executing, and they intercept all the system calls. Mm-hmm. So we could use that to kind of infer what was happening in the graphics pipeline. So which API was being used, which libraries were being called. But it feels like there should be something kind of more direct than that, because it felt like a very laborious way to be doing it. And like we were using this tool that like shows you which drivers are loaded on your computer to try and again infer that, but like actually making sense of it was really hard.
Yeah, that's a problem, that a lot of tools, they're analyzing so much data and it's difficult to find the important data.
Yeah.
I wonder if this is something that I've got a feeling that maybe Ben might address some of this stuff later on, potentially. And perhaps maybe Jacob Bornkrantz as well might be able to talk to some of this in some of his presentation, perhaps.
Yes, I'm Jacob Bornkrantz. I have a little bit background. I have worked for VMware with virtual machines on graphics, so basically specifically this problem, and I can probably talk about it for hours, so I don't really know just how much I can say. I can try and we can probably move this offline, I think, this discussion, because at some level I think this is probably the right way to preserve works, because there's just so much of the system that the artwork might need. So you basically just have to make a capsule of the entire operating system, so you get all of the dependencies in from the artwork that you need. I think you probably might spend a lot of time just trying to just find everything that they might have had installed on their system and didn't really think about it or something like that. So yeah.
Okay, that sounds like some really good points for discussion. Maybe we hopefully have some time at the end of the day or something to come back to that. That would be really cool. I think in the interest of keeping everything on time, we'll have to say thanks very much, Claudia. And we'll move on to the next presentation. Have we got